How's it going, geometry students? This is Mr. Sheck with your Unit 7 Geometry Test Review tutorial video. Again, how I start every video, okay? Do not just watch this through copying everything down. That's not the way to use this video. That's not going to benefit you come likely tomorrow if you're watching this. Tomorrow is probably test day if you're watching this. So that's not going to do anything for you. Again, I don't even grade this, but I can tell who used the video correctly, who really took their time to try understand each of these problems. Because those that do that, they do well on the test every time. And those who don't take this seriously or just copy it down to get it done, well, that's doing absolutely nothing for you. So make sure you're going through this, thinking about each question, trying to do each question on your own. Maybe you're like, I don't know how to set this one up. That's when you hit that play button, watch me set it up, then hit pause right away and say, okay, now that it's set up, what do I have to do? Try to do it on your own, and then go from there and then hit play to watch me do it to see if you did it correctly or where you went wrong if you did make a mistake. Okay. So use this video in a way where it's checking your answers, helping you get unstuck when you're stuck, stuff like that. Okay, now, very first one. Okay, a little tricky because we're talking about triangle. This unit has been mostly right triangles because we're talking trigonometry. Unless we're talking law of sines or law of cosines, then it's not right triangles. But it's asking for the tangent, so it's got to be a right triangle. And then you got to think, okay, which one is my longest side? That's my 15, so that's got to be my hypotenuse. So I'm going to draw a right triangle in here. Since we're talking tangent, I know it's a right triangle, and then you know that this DF has to be my hypotenuse because that's my longest side. Okay. From there, we can call this D, or sorry, we can call this E, and it says DE is 12 and EF is 9. Okay. And then it's just asking what is the approximate value of the tangent of D? Well, here is D up here. Okay. And the tangent, you have to think TOA, okay, opposite over adjacent. So that's opposite is across from it, that's 9, so tangent of D equals opposite over adjacent. That's 9 over 12, okay? Opposite over adjacent. Okay, again, it says EF is 9. It says DE is 12, so that's how I knew how to label this. Tangent of D equals 9 over 12. Approximate value of 9 over 12, well, that's 3/4, okay, or 0.75, okay? That's your answer there. Okay, that reduces to 3/4, or you can just do 9 divided by 12 in your calculator. It's 0.75. Okay, moving on down. Again, I am also going to go a little bit fast, it may seem at times, but that's because you're just using it to check answers and hear that explanation, and you have the ability to pause, slow it down, rewind, stuff like that. Okay, here we're trying to figure out if they're similar, if these two triangles are similar, and we want to use tangent to find that out. Well, again, if we're going to use tangent, okay, well, we can use, how about W and L, okay? Those are the two vertices by the lawn side, or adjacent to the lawn side, I would say. So I can go ahead and I can say, well, tan of W, again, that equals opposite over adjacent. That's 3/6. And then tan of L, if they're similar, they should be the same. Tan of L is opposite over adjacent, 7.9 over 23.7. And again, adjacent is the one touching your angle. That's not your hypotenuse. Hypotenuse is always across from your right angle or your longest side. Okay, so it is always going to be this one. This is your hypotenuse. Adjacent is the leg that's touching your angle. Okay, 7.9 over 23.7. Well, that is not 3/6. It reduces to 1/2. This does not reduce to 1/2. So their tangents aren't the same, and therefore, no, these triangles are not proportional. They are not similar. Okay. Moving on from there, we have a triangle, not a right triangle. Okay, we don't see any right angles, but it's asking for what is the area. And if we're going to find the area, we need to find the height of this triangle first, because it's base times height divided by 2. Okay, and we have what we could use as bases here. But again, when we're drawing in our altitude, the only place we really don't want to draw it in is here, because then we're cutting the one angle we know. And we need to keep this 30 degrees as a 30-degree angle so that we can use it. So I would draw my altitude right in here. Altitudes go through a vertex and are perpendicular to the opposite side. Okay, so from there, well, then that means this has to be a base of 5 and a height. We're just going to call the height x for now. And if that height is x, okay, well then we got to think, all right, what can I use here? If I'm using this angle and we're using the opposite side, and that would be the hypotenuse because it's across from the right angle. So that is going to be, okay, what uses opposite and hypotenuse? So we're thinking SOHCAHTOA, opposite and hypotenuse is sine. So we're doing the sine of 30 degrees, and that equals our opposite over our hypotenuse. Okay, from there you've got to get your x alone, so you're multiplying 5 by both sides. That will get our x alone. X is going to equal 5 times the sine of 30, which is where you go to your calculator. You go 5 times the sine of 30. Oops, I did tangent. 5 times the sine of 30, not tangent of 30. Okay, and that is 2.5. Okay, so that's going to be your height, not your area. Okay, area is base times height divided by 2, so we're going to use that now. Okay, base is whatever you drew your height perpendicular to, so that's going to be 5 times the height, 2.5, divided by 2. Okay, 5 times 2.5, that is, we're just going and doing that in the calculator. 5 times 2.5 is 12.5. 12.5 divided by 2 is 6.25. So that is the area there. Okay. Moving on, we are now on question 4 of what looks to be I think this is a shorter review. It's a 9-question review. Okay, so we're getting there. Looking now, we have a surveyor measures the boundaries of property with the dimensions shown. Okay, so we're looking here, and it does not look to be a right triangle again. So if it's not a right triangle, you can't just go ahead and use sine, cosine, and tangent. You have to think, okay, probably law of sines or law of cosines. So from there, you are going and saying, okay, well, what are we trying to figure out? What is the distance from the surveyor to site A? Okay, so I would mark that with an X. Okay, and then you got to think, okay, well, what do we know? And we know this is 78 degrees. We know this is 36 degrees. We know all 3 angles of a triangle add up to 180. So we could do 180 minus 78 minus 36 to find this one up here, and that is going to be 66 degrees. Okay, from there, you're thinking, okay, law of sines or law of cosines. In this case, you can use your law of sines. So we know sine of 66. Throw that over the side opposite, which is 44 feet. Set that equal to, okay, sine of 36 over the side opposite to it, which is x. Okay, once you have that proportion set up, you are then going there and cross multiplying. Okay, so you can draw your butterfly wings in 44 times the sine of 36 is going to equal sine of 66 times x, or x times sine of 66, however you want to write that. Okay, and then lastly, if you're going to get your x alone there, you've got to divide both sides by sine of 66. And then you go to your calculator because x is alone. So x is going to equal 44 times the sine of 36. I would hit enter there, and then you divide by your sine of 66. You get 28.31. that is your X. That is your distance from the surveyor to site A. Okay, moving on. Again, remember to pause this video, slow it down, rewind it. I'm going to start picking up the pace here to make sure I finish in the 30 minutes that I have before I get cut off. So use this video to just use it to your advantage in a way where you are understanding, not just copying down, going at a rapid pace, because I'm about to pick up the pace here. Okay, so going on to the next one, we have a roof supported with a triangular truss that has the dimensions shown. Okay, and we're trying to find the angle formed by the left side of the truss and the base to the nearest tenth. Okay, well, here's that left side of the truss. Here's the base. So we're looking for this angle here. And then you got to think, okay, we got to use the 4 and 10. Well, the 4 is the opposite, the 10 is the adjacent. So what uses opposite and adjacent? You're thinking SOHCAHTOA, TOA, opposite, adjacent, that's TOA, that's tangent. And when we're looking for an angle and we have the sides, we need to use inverse tangent. So we're using inverse tangent of opposite over adjacent, 4 over 10. And then that's as simple as that. You put that in the calculator. You hit second tangent, 4 over 10. Or 4 divided by 10, in other words. That's going to be 21.8. I said 2.8. 21.8 degrees when you round. Okay, this next one, a little tricky one that you have to draw out. We have a person parasailing in the air, and they're attached to the back of a boat by a rope. The distance from the person to the boat is 850 feet. Okay, so you need to draw this out. Draw out this situation with a right triangle. Okay, draw it in like this. We have a boat here. If you want to draw out the boat so you can really visualize this, go ahead and do that. Here's my little boat, the little sail, whatever you call that. And from there, you're thinking, okay, the person to the boat is 850 feet. Okay, and it really should say horizontal distance from the person to the boat because that is going down here. Okay. From there, the angle of depression is 29 degrees. So that's really like saying this angle up here is 29 degrees, but we want to be able to use that in our right triangle. Think alternate interior angles. So this is 29 degrees down here also. And then we're trying to figure out if the rope is attached to the boat 5 feet above the water. Can't forget about that. That's going to be something we do at the end. What is the height of the person above the water? That means this vertical distance there. Okay. From there, you're thinking, okay, we are using this angle of 29 degrees, and we have our opposite side, and we have the side touching it. That's not the hypotenuse. So we have our opposite and adjacent again. What uses opposite adjacent? Think SOHCAHTOA. That is tangent. So we are going to use tangent of our angle that we have, 29 degrees, equals opposite over adjacent, x over 850. Okay, from there to get x alone, you're having to multiply both sides by 850. That gets our x alone. We go to the calculator, 850 times tangent of 29. It's going to be 471.16. And again, we're trying to, we have to use that 5 feet above the water now because we're trying to figure out how high above the water the person is. Well, this person is 471.16 feet above the boat. The boat is another 5 feet above the water. So we have to add 5 feet to this at the end. So 471 plus 5, that's 476.16 feet above the water. Okay, moving on to number 7 out of 9. Okay, a cable car transports passengers along the side of a hill with the dimensions shown. Okay, what is the angle of elevation from the bottom of the hill to a cable car at the top of the hill to the nearest tenth of a degree? Okay, angle of elevation, you're thinking, well, that's here. Okay, from there, if we're trying to find an angle, that's how you know you're using your inverse trig functions. And again, you have your opposite side. You have your adjacent side. You don't know your hypotenuse. So you have to use what uses opposite and adjacent once again coming up to be a little bit of a trend here. We're using that tangent. And again, it's inverse tangent because we are looking for the angle, not a side length. So inverse tangent of opposite is 90 over adjacent is 542. That's going to give us that angle of elevation. Push a couple buttons on your calculator. Second tangent, 90 divided by 542. And that angle of elevation is 9.43 when you round. Okay, 9.43 degrees. Does that make sense? Yes, it does, because we're 542 meters away here, going up only 90 meters, so it should be at small angle of elevation. 9.43 degrees makes good logical sense. Moving on to 8. Okay, we have triangle PQR, and the measure of angle P equals 103 degrees. PQ is 12 inches. Angle Q is 36 degrees. Okay, I would draw this out. If you have a 103 degree angle, you should know, well, there's no way this can be a right triangle then. Okay, if there's a 130 degree angle, let's throw that guy up here. We'll do PQR like that. If there's a 103 degree angle, there can't be a 90, because 103 plus 90 already gets you over that 180 degrees in every triangle. So we'll call this 103 up here. PQ then is 12 inches. Label it 12. Angle Q is 36 degrees. Okay, and if you're given two angles, well, then you know the third, because the third has to get you to 180. So I would go 180 minus 36 minus 103. That is 41, so that means this last angle here is 41 degrees. We needed that so that we could use the law of sines. Okay, what is the length of QR? That's this length here. I will call it x. Now I can go ahead and use the law of sines because I have an angle and the side length opposite to it. So I'm going to use that. Sine of 41 over side opposite to it, 12, equals, okay, and then I want to find x here, so that means I'm using the angle opposite of x. That's sine of 103 over x. Okay, once you have this set up, you're cross multiplying. X times sine of 41 equals 12 times sine of 103. Okay, you got to get x alone. Right now, x has sine of 41 being multiplied by it. What's the opposite of that? To divide by sine of 41. That's what's going to get your x alone, and then you go to the calculator. 12 times sine of 103 you have to do first. Hit enter, because your calculator does not necessarily know order of operations. Then you lastly divide that by sine of 41. Oops, not by 41, by sine of 41. Very different. And that's going to be 17.82. Okay, so that's the answer to part A. That gives us the length of QR. What is the length of PR? We'll call PR Y, and it's the exact same thing, guys. It's law of sines. This time you need to use the angle opposite of Y, so that's sine of 36 over Y. And then you can really use either one. Now let's use angle R and the side opposite, so we're not dealing with decimals. We'll do sine of 41 over 12 again. Okay, and it's going to be that exact same process, cross multiplying. I'm not going to work this one out for the sake of time. I don't know if I'm running out of time, and I don't want to get cut off on the last problem because it's a biggie. Okay, but it's going to be that exact same process. Let's see if I have it solved out here so I can tell you what you should get. No, I didn't solve it out on my answer key either, but the answer key will be posted on Google Classroom for you. All right, moving on to number 9, which is the last one here. Okay, draw your triangle. It's triangle RST. We'll call this R, we'll call this S, we'll call this T. We have to then just label it correctly. They're saying RS is 27 feet. Label it 27. They're saying RT is 28 feet. Label it 28, and they're saying angle R is 29 degrees. From there, you are going to have to use the law of cosines, which is everyone's least favorite thing to do because it's a big formula. Okay, but whenever you have a side or two sides with the angle between them, and that's it, you got to use the law of cosines. Okay, so law of cosines says that, and we're trying to find this side because we need the perimeter. Okay, so we will call this A for now, and that side, A squared, equals, and I will give you, I'm hoping, I haven't talked with the other geometry teachers, but I'm hoping we will be able to give you this formula. You shouldn't have to remember the law of cosines formula. And A squared is going to equal your other two sides squared added together. It's 27 squared plus 28 squared. Okay, minus then 2 times the two sides you have again, so 27 and 28, times the cosine of that angle you have. Okay, that's a biggie. So from there, you're going on and you're simplifying. So A squared equals 27 squared plus 28 squared. I would do in the calculator, and that's going to be 1513. It's 1,513. Okay, subtract that by, and then you're doing this part in your calculator. So 2 times 27 times 28 times the cosine of 29. Enter. It's about 1322.4. Okay. From there, you're just subtracting the two. So 1513 minus 1322.4. That gives you 190.6. So, and that's A squared, remember. A squared is 190.6. So to find A, that side length, you need to take the square root of 190.6. So you go square root of 190.6. That gives you 13.8 when you round. So that is your third side length. This is asking for perimeter here in part A, so now you have that third side length, and you just add them all up. 27 plus 28 plus 13.8 gives you the perimeter, and you should get 69.8 feet as your perimeter there. Okay, part B, and the very last one on this review, is what is the area of triangle RST? Well, if you want the area, you need that height. So you have to go ahead and draw in an altitude, drop down your altitude, your height from, I would say, vertex S. You can't go through vertex R because then you're cutting the angle you know. So I would say drop it down from S, and from there, you're trying to find this right here. That is your height. Okay, and you can't use the 28 because you're cutting it by your altitude, so you need to use the 27. So that means you're using the side opposite of your angle and the hypotenuse. So what uses opposite and hypotenuse? Think SOHCAHTOA. Opposite hypotenuse is in so that means you're using sine of 29. That's going to equal your opposite over your hypotenuse, x over 27. To get that x alone, you got to multiply both sides by that denominator. To get it out from underneath it, to get it to cancel, x is going to equal 27 times the sine of 29. And that is 13.08 or 09 really when you round. That's your height. Now that you have your height, you can find your area by doing base times height divided by 2. Base is always going to be what is perpendicular to the height that we dropped down. Well, we dropped our altitude down perpendicular to 28, so 28 is our base. We found that altitude or height to be 13.09, and then divide it by 2. That is going to be your final answer. 28 times 13.09. Enter, divide that by 2, 183.26 feet. And we're talking area, so that's feet squared, square feet. Okay, that is a wrap on your Unit 7 geometry review. Good luck. You're probably taking the test tomorrow if you are watching this. So take care, have a good rest of your day, and be ready for that test.